Hi everyone, Mr. Masura here. So in this example problem for acceleration, we're going to find not the acceleration or the final velocity like we've done earlier. This one actually asks us for its initial velocity. That changes the math a little bit, but despite those differences, it still follows the same steps of showing work that we've done the whole time. So let's look at this problem. A school bus begins to speed up with an acceleration of 2 meters per second squared. 3 seconds later, the bus is moving at 20 meters per second. How fast was the bus going when it first began to accelerate? So let's start the way we always do, by making a list of what we know. It says it speeds up with an acceleration of 2 meters per second squared. So we know A equals 2 meters per second squared. Then it says 3 seconds later. Well, seconds measure time. So T equals 3 seconds. It says 3 seconds later, the bus is moving at 20 meters per second. Now let's think very carefully here. Is the bus moving 20 meters per second at the beginning of the problem or at the end of the problem? Well, since this is happening later, that tells you that this is how fast the bus is going at the end. That means that this is our final velocity. And finally, it asks, how fast was the bus going when it first began to accelerate? Well, that's asking us how fast it was going at the beginning of the problem, which means our question mark is our initial velocity, VI. So whenever you use this formula, you notice that it'll give you any three of those, and you have to calculate the fourth. So we start with what we know, and then we choose our formula. Well, the only formula that has initial velocity in it would be our one for acceleration. A equals V little f minus V little I all over T. Then we plug in the numbers. We know that A is equal to 2. On our fraction, we've got VF, which is 20, minus VI, which we don't know, so we leave it as VI, all over T, which is 3. So our next step is to solve it. Now we're going to solve for VI just as if it were X. So we got to start by getting rid of that fraction. And the best way to do that is to multiply both sides by 3. So 3 times 2 gives us 6 on the left. And on the right, we have 20 minus VI all over 3, all times 3. That means that these will cancel each other out. You notice that it just gets rid of the fraction. It does not change what's on the top. So we're left with 20 minus VI. Now, there's a couple different ways you could solve this from here. I'll do one of them, but you have to be very careful about your signs in particular. Right? So, we can start, let's see, we got 20 minus VI. We can get rid of that 20 by subtracting 20 from both sides. Well, 6 minus 20 gives you negative 14. And 20 minus 20 minus VI gives you negative VI. Don't forget about that negative. That's still there. And finally, we have negative 14 equals negative VI. Now, you'll notice that we don't want to know negative VI. We want to know positive VI. So all we have to do is flip the signs. Now, there's more than one way of doing this. But the way I'll do it is I'll multiply both sides by negative 1. And if we multiply both sides by negative 1, that should flip the sign. So it will give us positive 14 equals positive VI. And then we just need our units. So that will be meters per second because it's a velocity. And we box our final answer. So in this example, you notice it's the same steps that we've used for every single formula. The only part that's different is when you're solving for VI, you've got to be more careful about your algebra here, right? You have to get rid of the fraction, and then doing the next two steps, be very, very careful about your signs. You can imagine a lot of people will accidentally do 6 minus 20 and put positive 14, forgetting that 6 minus 20 gives you negative 14. Likewise, when people subtract the 20, a lot of people will forget that there's still a negative VI there. If you make a sign mistake, you notice your initial velocity will come out negative. That shouldn't make much sense, right? If it had a negative velocity, that would mean the bus was moving backwards at the beginning of the problem. And that doesn't make any sense, right? So if you get an answer that's unexpectedly negative, it should make you pause and say, I better double check my signs in case I made a sign mistake. All right, well, have a great day, everybody.